Alright, in part one of calculating half breadths, I showed you how to create these vertical and horizontal planes that equate to station areas and also the waterline planes. So I'm going to show you in this video why they're becoming very useful in order to calculate very accurate measurements of half breadths, which is the distance between the center line of your boat and the hull of the boat. So I'm going to show you real quick. I'll just go ahead and get started. I'm going to maneuver my boat around so I can calculate the port values. The reason I'm going to calculate my port values first is because they've got a mirror command in your spreadsheet that the shipyard gave you that will calculate the half-breadth distances for the port side, and the mirror command will simply copy and paste it over to the starboard side for you. However, if you start with the starboard side, it won't mirror it to the port side. So we have to calculate the port side values first. Now, we had a lot of trouble calculating the half-breadth distances for curved planes. We had a lot of trouble with this, and I'm going to show you how we got around it and managed to figure it out. Basically, the half-breadth distance, we've got to make a mark between a 3D intersection between these station line planes, the waterline planes, and the hull of the boat. Okay, we did pretty well on flat surfaces, but again, curved surfaces were a pain. We actually had to create what's called 3D sketches, and I'm going to create a 3D sketch. And we actually had to draw or sketch lines where the water lines, these planes, intersected with the hull of the boat. So that's really easy to do. You just simply hold the control key down and select a waterline plane. I'm going to select the waterline 6, and you see how it passes through the hull of the boat. And also I'm going to click on the hull shape, the curved shape of the boat. So I have those two areas selected, and I'm going to create a 3D sketch there. And I'm going to use the 3D intersection curve tool. And my first selection is going to be the curved surface of the boat. And then I'm going to select the waterline plane and click OK. Now I'm going to continue to do that. You notice it creates this red line. That's going to become very useful for you here shortly. I'm going to do that again. I'm going to create, I did this for all the waterline planes. And I'm going to create another one. And click OK. And you see those three lines I created, and then I right mouse click, finish my 3D sketch. Now I can go back and I can show you where this becomes useful. Alright, this is station area 0. And of course all your half breadth values are going to be 0 for this one. Station area 1, we need to get the create a work point that's going to be the intersection of this plane and these lines. And I'll show you how to do that. So I'm just going to hold on to the control key, and I'm going to press station area 1. And you see how it passes through my hull of my boat. I'm also going to hold the control key down and select that red line we just created. And now when I create a work point, you'll see that my work point is selected, and that is the point where all these three planes intersect in the hull of the boat. I'm going to do that again, and I'm going to hold the control key down, select that red line, and do another work point. I'm going to create another one. You see, I would do this for all 7 waterline planes. And now I can go back and measure my distance, use the tools, measure distance. I'm going to have this origin. I'm going to click on the center point of the origin. and click on my first work point, and you see right here um, I've got the blue distance, the blue arrow in my model is the z-axis, which is the transversal distance. That's what I want. This is port side. It's going to be, even though it says negative 12.267 inches, that's the port side, and you would enter it as positive in the spreadsheet. So I'm going to go, this is station area 1, waterline 6. So I would go to my Microsoft Excel spreadsheet, station area 1, waterline 6, and enter negative 12.267 divided by 12. So I'm going to go up here, port edge center hole station 1, 6, and I would put 12.267 divided by 12. That would give me the answer in feet. I forgot my equal sign. And I would get 1.022 feet. Let me go back and do that. I'm going to measure the distance again from center point to the other one, and I've got negative 11.765. So that is 5, waterline 5, station area 1. So I would go to port edge center hole station number 1, waterline 5, and I would enter 11.765. Divide by 12. And I would do this for all my water lines and all my hull stations. I would use the same process over and over till I get them all done. Now, there's a couple of things. I told you about the mirror command. Watch what happens when I press the mirror command. In my bottom, you'll see in starboard edge center hole station number 1, they become, waterline 5 and 6 become negative values. You see negative 0.98 and negative 1.022 feet. So you only have to do the port side, but again, this is a method that will give you very, very accurate half-breadth distances in your model. Now again, I'm not finished yet. I want to show you one more thing. Again, this was for curved surfaces. I didn't necessarily need to use the 3D curve for my rectangular surfaces. Up here, I would simply, this is station 1, 2, 3, 4, 5. I'm going to go to station 5. All right, and I'm going to zoom in on station 5. And what I want to do is I want to make a work point on station 5, waterline 6, and that side hull, and I can create a work point. And you'll see it creates my work point there, and I can do the same thing. I'm going to click Tools, measure distance from my center point to that one. I get a Z value of negative 20.509. Okay, so I would go to my spreadsheet, negative 20.509, and again, that's station 5, waterline 6. So I would go to my station 5, waterline 6, and again, that was 20.509 equal 20.509 divided by 12 to give me feet. Okay, and again, I could simply hit the mirror command to give me that. Again, on the starboard edge, center hole station 5, it would be negative 1.709. In this method, what I've done is use work planes to show you how to create really accurate half-breadth distances, and to create that Excel spreadsheet to fill that out very, very accurately using a 3D modeling program.